So students, in the morning class, we have seen the radiation shield concept. Now, uh, in continuation to that, I would like to tell you some more cases wherein this concept of QNet and interchange factor will help you out. Okay, so if you take the case of infinite parallel plates, you will have F12 formula and equivalent emissivity or E bar or interchange factor. These formulas are there here. So there is one more case which you may come across in the problems. That one is a small body in a big enclosure. That is, if I take a enclosure like this, which is very big, which is one, and you have a very small enclosure, sorry, small body like this. Let me call this as 2. If this is the case, what will be your F12 and what will be your equivalent emissivity? You should be knowing. Small body in large enclosure. This is one more case which you may have, or you may also have body in a body. This is a body 1, and here outside 1 is your body 2. If this is the case, what will be your uh, F12 and what will be your equivalent emissivity formulas? You must remember. Okay, F12 is anyways 1 in all these cases. So because whatever the heat that is there is exchanged with only one body, it cannot be taken by itself, kind of. Okay, so here, what will be the equivalent emissivity formula? We have seen it in the morning is 1 by epsilon 1 plus 1 by epsilon 2 minus 1. This we have seen. And coming to this one, I'm telling directly, this is simply epsilon 1 you will have. Okay. So if you have a case like this, body in body, it can be a cylinder in cylinder or sphere in sphere. Both cases can be there. It can be anything for that matter. It can be cube inside a cube. It can be anything inside anything. Okay, it's a body inside the body. If that is the problem, what will be the equivalent emissivity formula? In that case, 1 by epsilon 1 plus A1 by A2 into 1 by epsilon 2 minus 1. This is the formula that we are going to take for. Now let's solve a simple problem based on this. So here I have given this question. Here the question is about a spherical tank. So this is your question, and here the question is about a sphere. That is spherical tank case is given. The diameters are given. The D1 is equal to 40 centimeters and T1 is equal to 100 Kelvin and D2 is equal to 60 centimeters and T2 is equal to 300 Kelvin. Emissivities of the inner and the outer tank, epsilon 1 is equal to 0.15 and epsilon 2 is equal to 0.2, and what else is given? A spherical radiation shield, that is epsilon 3 is speaking about, is 0.05, and corresponding D3 is given as 50 centimeters. What is the meaning? Is 40 and 60, and this one is 50, meaning the shield is kept in between these two. So that's the meaning of this D3 here, and the epsilon 3 is given. So what he's asking you to find is asking you to find calculate the rate of heat loss. Okay, this is the thing he's asking. Calculate the rate of heat loss from the system by radiation. So firstly, he's asking you to find Q. So how do you find Q? Tell me, what is the formula? In the morning we have solved now. What is the
Sigma
formula?
over 4.
Q is equal to Q12, you can take, so is equal to sigma into T1 to the power 4 minus T2 to the power 4 by what should be taken in the denominator?
IF.
What? I cannot hear you clearly. Can you speak clearly?
Resistance.
The resistance you have to take. Yeah. What is that resistance I am asking?
Body in body.
Body in body resistance you have to take. Correct. What is that you are going to take here?
1 by
Simply,
E.
this one you can take. So not this one. This one you have to take. Okay. If it is just one sphere, but here you don't have one sphere. You have one more sphere in between the two spheres. So if that is the case, what you have to do? Draw the resistance, then you will understand. Okay, so this is the first cylinder of first sphere of so and so diameter. This is a radiation shield. This is one more. So you have three here. If you have three, what will be your resistance circuit? First you will have the surface resistance due to the first one, and then we will have space resistance, and then what is the resistance you are going to have? The resistance due to the radiation shield on side 1, on side 1, and you have radiation, sorry, resistance due to radiation shield on side 2, and then we have resistance due to space, and then we have resistance due to surface. So let me call 1 on this side, 2 on this side, and then this is space. So what will be the formula for this one? Tell me. Space, what is the formula? Please speak out.
1 by A1 F1.
For space, 1 by A1 F1 2. This one, 1 minus epsilon 1 by epsilon 1 A1. So how about this one? 1 minus epsilon of 3 1 by epsilon 3 1 A. Here, 1 minus epsilon 3 2 by epsilon 3 2 A. Space 1 by A2 F2. This is actually F1 3. This is F2 3. This one is 1 minus epsilon 2 by epsilon 2. Yeah, the same formulas that we have used previously. We are using it again. That's the only difference. So what you will do? you will take sum of all these things. These are the series. You will take sum of all these things and then substitute it in the denominator. When you substitute it in the denominator, what happens is it will take this form here 1 by epsilon 1 plus a1 by a2 into 1 by epsilon 2 minus 1 plus a1 by a3 into 1 by epsilon 3 1 plus 1 by epsilon 3 2 minus 1. So this is a simplified form of this whole thing. Okay. So either you can use these things barely, you can calculate using each one and you can substitute. Otherwise, you can solve it using this formula also. So it's up to you. So let's substitute the values here. One is missing in the number actually. Like that. So if this is the case, what will be your A1? Tell me. What is the surface area of sphere? Yes, please speak out. If you can't speak, I cannot help actually. It is 4 pi r square, or it is also equal to pi d square. Anyone you can use, since the diameters are given here, we can use pi d square. So it is like I'm writing it here. Area is pi. The d value is 0. It is 40 centimeters. Let me write that down. 40 into 10 to the power of minus 2 whole square into sigma value is 5.67 into 10 to the power of minus 8 watt per meter square Kelvin power 4. The T1 value is given as 100 Kelvin. The T2 value is given as 300. See, very important thing here is this values can be given in degree centigrade also. When it is given in degree centigrade, you must substitute it in Kelvin only. In exam, he may give you Kelvin, or he may give you degree centigrade. Okay, whatever may be the unit given for the temperature, while you are substituting in place of T to the power of 4, always remember you should substitute that only in Kelvin. Okay, right. So what is the epsilon 1 given in question? Chapter 0.15, 1 by 0.15 plus what is the area 1? It is pi d1 square, that is 40 into 10 to the power of minus 2 whole square by area 2 pi into the 60 into 10 to the power of minus 2 whole square into 1 by epsilon 2 is 0.2 minus 1 plus the A1 is pi d is 40 centimeter square by pi into 50 into 10 to the power of minus 2 whole square into 1 by epsilon 31. On both sides, it's given as 0.05 in the question by 0.05. This one. This is the expression simply. So tell me what is the Q value. Tell me what is the Q value. Please calculate and tell me. What you can do is like you can do the numerator and the denominator separately. That will be probably very comfortable to you. Are you doing చేస్తున్నారా లేదా Please speak out, or simply I will tell the answer.
Just look.
Yeah, yeah. The answer will be minus 6.83 watts. Okay, you can do it. You will get this. Minus or plus is okay, but ultimately you should get this 6.83. That is the point here. Okay, so that's the Q. Apart from this Q, he is also asking something else in the question. Find the rate of evaporation. How do you do this? Has given some 2.1 into 10 to the power of 5 watt second per kg is given. So what is asking is kg per second is asking. So reverse of this is asking. So you multiply this 6.83 with this one, then you'll get it. That is 6.8 by 6.8 watts by 2.1 into 10 to the power of 5 watt second by kg. What get cancelled? You'll get so much kg per second. This will be rate of evaporation. Is that clear? Rate of evaporation is a simple thing. Okay, Q is equal to m dot into HFC kind of. This is HFC given to you, and is asking you to find out this m dot. Okay, so Q is known. Q by HFG you have done simply. So anyway, you can do it. I hope that's clear to you. Shall we move ahead? The next concept in this, do you have any questions? See, I have given the cylinder example in the assignment, so solve it for yourself. Cylinder example can also be a question for you, so solve the cylinder example also, and that will be of use to you. Where is that assignment? Yes, so yeah, here this questions you can see. This is a parallel plates like we have solved in the morning. Okay, that kind of question. And here, this question is a cylinder question. It's a tube, long tube question. It's a cylinder question. So you solve it for yourself, you will understand. And then third question is a cylinder question. It is a spherical vessel given. Okay, temperatures are given, and the emissivity is given, and diameters are given. So everything is given. So you have to find out what is the um, Q value. So that's the thing. So in case of plate, cylinder, and sphere, you have to do it. You have to practice it. That's why I've given all the three kind of things in the assignment itself. So practice it well.